Hey, folks. Because we're here, I'd like to do a quick little supplemental, which will lead us into some work for later. That I asked the question before about how much time does it take to stop, and we solved some pretty cool stuff, plugging them all in together and walking away with these two kind of new equations here, which is the acceleration here is nothing more than the coefficient of friction times the acceleration due to gravity. And then the amount of time then is the change in velocity divided by that acceleration, which is the coefficient of friction times the acceleration due to gravity. And with this particular kind of 24.6 meters per second is my starting amount, I found out that it took 3.14 seconds in order to slow down and stop. But the supplemental that I'd like to address here is not just kind of how much time it takes to stop, but how much distance does it take to stop? How much distance does it take to stop? This is kind of a delta x. I want to say, how far does it travel while it is stopping? Well, in order to do that, I'm going to get some numbers here for this acceleration because we'll need those in just a moment. So this is nothing more than kind of this zero point 0.8, which is the coefficient of friction here, times the 9.8, which is negative again. So this is 0.8 for the coefficient of friction here, times this negative 9.8 meters per second every second. And 0.8 times 9.8 gives me value. Let me go ahead and calculate that. So 0.8 times 9.8. I can type in that in, right? I walk away with a negative value, because here it is, of negative 7.84. And that is going to be in meters per second every second. All right, so I have these two quantities. I have a change in time of 3.14 seconds, and I've got an acceleration of negative 7.84 meters per second, right? Because I'm slowing down. So these are my two pieces of information that are going to come in pretty darn handy in just a moment. In fact, I'm going to underline them in red so that we don't lose them. All right, so if I'm asking questions about how much distance, it's been a little while, but when we did our first chapter challenge, we had an equation that I dropped on you that I said kind of came out of nowhere, and we used it quite a lot to be able to calculate the positions of where the car is in any given frame. And that equation, if you remember, was a change in x, which is that position, so change in position, is equal to a 1/2 times an acceleration times a certain amount of time squared plus an initial velocity, so starting velocity times that amount of time. And when we were doing it for our kind of chapter challenge, the first chapter challenge, we went ahead and started plugging in times for whatever frame we were in, and we found out exactly where we should put the car. Now, in this case, we're going to use this formula in the exact same way, only we're going to plug in our accelerations here with negative because we're slowing down, and the times for the amount of time that it takes for it to slow down and stop. And that combined is going to give us this delta x that we were looking for in the first place. So I can actually just plug things in here to be able to solve this out. So I'm going to do that in blue just down below. So I'm going to go ahead and say this is equal to 0.5, because I'm going to do this in a calculator. So I'm going to put that 0.5. Secondly, I'm going to put in my acceleration was this negative 7.84 meters per second every second. And I'm going to multiply that times my amount of time, which is this 3.14. So 3.14 seconds. And I need to square that piece. Now the square is only squaring the time, so that's really important. It doesn't square this and it doesn't square this. And then I'm going to go ahead and add this. You'll notice that this whole thing is going to become negative here. And I'm going to add that to my starting velocity, which is 24.6 meters per second. And I'm going to multiply that times time, which is the 3.14 seconds. All right, so all combined, we just plugged in all of those numbers here, where this is my 1/2, right? Let me go ahead and kind of point these out. This is my 1/2. Here's my acceleration that is negative. Here's my time that I've squared. My starting velocity is here, and my time is there. So I've just plugged in my things. And so now it's kind of time to chug out an answer. So if I grab my handy dandy calculator here and I type 0.5 times negative 7.84, that looks good so far, times 3.14 quantity squared plus 24, oops, I've timesed it, I need a plus 24.6 times 3.14, I walk out with a number here that is equal to, I'm going to do this in blue here, equal to 38.6 meters. Now, how do I know it's meters? Because I've got a seconds that cancel out. I'm adding on to this here. We've got, the only thing I have left, the seconds cancel. Here, the seconds squared cancel with this seconds squared, and then this seconds cancels out with that seconds, and the only units I have left are meters, so I have got meters down below. Now, 38.6 meters. 38.6 meters. Is that very far? Well, we often don't think in meters. We think in maybe feet or in miles. But if I was to take 38.6 meters and I wanted to say to feet, for instance, it's approximately multiplying by 3. But if you multiply by the actual numbers, the 38.6 meters is equal to 126.6 feet. Is that far? Well, when you think about it, a football field is often a common unit of measurement in the United States. A football field is about 300 feet. So this is not quite, but almost 1/2 of a football field, right? Not exactly, but close to that. So if that's the case, if you're traveling at 24.6 meters per second and a deer jumps out of the road and you hit the brakes as fast as you possibly can and go into a slide, you will stop about a half a football field later, which means that deer has to be spotted quite a distance in front of you so that you can actually stop and not hit it if you're going to do it. Of course, we often swerve, which is important to be able to get out of the way, but sometimes the deer moves in front of us, which is tough. So if you see that deer within, a shorter distance than 126 feet, you're going to hit it. And this is an important kind of aside. So there it is, 38.6 meters, which is the same as 126.6 feet. Just wanted to bring that up as a supplemental as to how we can use this change in position to be able to get to the last piece. All right, thanks everyone. We'll see you in the next one. Take care. Bye.